Good morning all. So on the last class we learned about valence bond theory. But there are some limitations in valence bond theory. What are they? We can't explain electrical and magnetic spectrum by using valence bond theory. So a new theory was published, that is crystal field theory. It explained completely the properties of the crystalline materials found, and also the electrostatic interaction between lone pair of electrons result in the coordination. The main assumptions of crystal field theory is metal and ligand is considered have high energy. We can separate them on the basis of their energy. And the coordinated metal and ligand bonds are stabilized. Okay, so the third one is there is a splitting take place in octahedral and as well as tetrahedral field. And we can destabilize the metal ligand bond by using the d electron repulsion. So these are the main assumptions of crystal field theory. Crystal field theory states that the electron pairs in the ligands are viewed. Here the ligand is considered as point negative charge, which is very important, and which interact with the d orbitals of central metal atom. Okay, so the electrons in the lone pairs or the ligands is considered as point negative charge, and they interact with the d orbitals present in the metal atom. And the nature of the ligand and the tendency to form the covalent bond can be ignored in the case of crystal field theory. We know that mainly d orbital exists in 5 forms. First one is dx square minus y square. Second one is dz square. Third one is dyz. Fourth orbital is dzx. And fifth orbital is dxy. Now we look how the ligand approaches in octahedral field. Ligand approaches in octahedral field by repulsion between these lone pair of electron and d metal orbital electrons. Okay. So here is what happened. In octahedral axis, d orbital is aligned along the axis, and most of the ligands can attack the central metal atom because of high energy of d orbitals. So here is the thing happen here. Splitting take place here. So this is the metal and ligands which is separated by using electrostatic interaction. When the ligand is entered to this central metal atom, it gets splitted into 5 energy level. 2 on first level, 2 on the upper level and 3 on the lower level. And this gap, this difference in the gap is considered as band gap energy. Okay. So splitting is take place into 3 on downwards and 2 on outwards. So originally the metal consists of 5 orbital atom. What happened is when the ligand is attacked with the d electrons of the metal orbital, it gets splitted into 3, 2. And these orbitals ligands are considered to be as dz square and dx square minus y square, which belongs in the set of Eg orbital. Okay. And another orbital set is T2G set that belongs from dxy, dyz and dxz. So dxy and dx first 2 orbital, that is Eg orbitals, have negative charge and the T2G orbitals have positive charge. So this is the upper set, that is while splitting the upper set is considered as Eg set, and while splitting the downer set is considered as T2G set, and they have the energy gap of 6 dQ and the lower set have the energy gap of 4 dQ. So the gap assigned by the value as 10 dQ. Okay, so this is what happened here. 5 orbitals are present. It is get split into upper energy and lower energy. Upper energy is EG set and lower energy is T2G set. EG set consists of dz square and dx square minus y square orbital, and T2G set consists of 3 orbital dxy, dyz and dxz. So in octahedral slitting, this is the energy difference take place there. Since it is on upper set, that is we consider it as a 0.6 delta 0. Lower set it is considered as minus 0.4 delta 0. This is the energy gap here. So splitting pattern is take place like this. 5 d orbitals are present and it gets split into 2 and 3. 2 consists of how many orbital? 2 orbital, and 3 consists of 3 orbitals is it. And this orbital considered as EG set and this orbital considered as T2G set. So I hope you understood the crystal field splitting take place in the octahedral field. So in octahedral field, what happen is there 5 orbital get split into 2 forms. One is 3 orbitals and another one is 2 orbital. Like that, the same kind of splitting is take place in tetrahedral field also. So the related link and the note is attached along with this video. Go through the link and download the notes. And don't forget to attend the test paper without any fail. So see you in the next class. Till then, take care. Bye.